I am going to first start by saying that I'm not an expert in AI as much as I am an expert in instructional design. That's where my background comes from. I studied instructional design at Utah State University, and so I come into this from an educational standpoint. And what I'm hoping to do today is to kind of educate people a little bit about different things that are kind of important for us to understand. I want to talk about bots, assistants, and agents and what those things are and kind of what we can do with them now and what we might be able to do with them in the future. It is an awesome thing to see one of these redwood or sequoia trees. When my wife and I went through the redwood forest there in California, I experienced a redwood tree for the first time, and I was dumbfounded. I couldn't believe it. And you see this picture over here on the left. This is the president. That's the name of this tree. It is over 3,200 years old. And you can see there's like a little person up here on top. There's a person down here below. They got people hanging from it. If you look, over here is just this lower branch right here. This picture, just this lower branch right over there. And when we talk about AI, a lot of times we think it's oh, it's this thing, but really you're like looking at like a side branch off of a main branch when you're looking at a specific thing with AI. And so it's a really big idea, and we can't explore all of it within 10 minutes. So I'm just going to explore some like a very small part of it. And when we talk about AI, there are usually four different kinds of AI that we're really interested in discussing. One is narrow AI. This is kind of like what Alexa and Siri does, although they're trying to bump it up so that it can do more things. Then you've got generative AI. That's what you've heard about here today is a lot about generative AI. And Chat GPT is probably one of the best examples of that. You put a message in, you ask it to do stuff. It can't do it on its own. You have to prompt it. It was never meant to be something that people don't have to engage with. It's kind of like your exocortex. You still have to have it plugged into your neocortex in order for it to do anything that's useful. Now, when we get to artificial general intelligence, this is where we have intelligence that meets or exceeds human task performance in a wide range of tasks. So we can help it learn new tasks that it can't do yet. And then we have artificial superintelligence. This is an AI that greatly exceeds human task performance, and it can create new tasks that we can't do on our own. Now, here's one thing I do know about artificial superintelligence. We haven't achieved it yet, but when we do, there's going to be part of it that's devoted to Curly. So Curly is going to be in there somewhere. So I have that to look forward to. Now, the head of Anthropic, they're the ones that put out Claude. He said the single most important thing to understand about AI is how fast it's moving. And when we look at research on how machine learning is growing, it grows basically through increases in three different things: the hardware, the training compute, the algorithms that are used, and then the training data set size. And we see that it is doubling. The training compute is doubling every 6 months. And down here, this chart is showing what a doubling every 6 months looks like over 5 years. Okay. And where are we at in this with the doubling? We're like right here. We're in this area, and we're about to see a huge increase in the power of AI. So how fast is it moving? If we look at the performance test, we see here it took it a long time to learn some of these things, but more recently it's just like shooting right up. It's getting to this human performance level very quickly. If we look at the context window size, the context window is kind of what it can think about. It's like its working memory. And the size of it has a big impact on how well it works. Well, if we go back here through the years, we see that this has been increasing in size considerably. And just a few weeks ago, Magic and Google, they combined together to get a brand new context window size that is basically the equivalent of 150,000 pages of text in a Word document. So imagine if you could memorize that in less than a second and you had perfect recall of it. What would you be able to do with that up in your head if you could do that? Another way we look at it is parameters. how many parameters do you have in a model? And parameters are kind of like synapses in the human brain. And if we look at these over time, we see that it's increasing on a logarithmic scale. It's going from tens to hundreds to thousands all the way up to trillions. And if we look at what's just happened in this deep learning era, we're seeing it doubling every year in general. But you see each one of these red dots is where it moves up by a factor of 10. And we're now up here in the trillions, working on our way to the tens of trillions. So when are we going to achieve AGI, that level of performance that's at the human level? They're talking between 1 to 5 years. This is what the leaders are all kind of saying. And they said this last year. So it's like it's coming very soon. So we have all of these large language models, and I've heard a lot of you talk about hallucinations here today. Does anyone here know why it hallucinates? Okay, I'm going to talk about that. If you're a wordsmith or if you were a chatbot, you would be a wordsmith. You would know a lot about words and phrases, a lot about grammar, you know a lot of facts and concepts, but you have a limited working memory, limited logical reasoning, and you'd need a lot of external context to be able to make sense of stuff. And you would live in this enormous mansion with billions of rooms, lots of doors, and you'd have to have different keys to get into the doors. There'd be a labyrinth of hallways and different things that connect the rooms. And in each room, you would have all of these magnetic poetry sets, and you would know every single possible combination of words within each set. And then you would know all of the combinations between the sets within the room. And so you'd have this vast knowledge of connections and what makes sense. And then you'd have a little robot assistant. We'll call him Wordy. And what he has is he has a word bucket. And the size of the word bucket depends upon the temperature of the bucket. And if you have a high temperature, you can get a lot of words in the bucket. And if you have a low temperature, you can barely fit anything in the bucket. And so you wake up one morning and you see this on your refrigerator. It says, get it blank the first time. So you're like, oh, what's the word? What's the word? I got to find the word. And you tell Wordy, go out. The temperature is at 1. So you can go out and find a lot of different words. And then this top P thing, we're going to get to that here in a second. So Wordy goes out, looks through all of the different magnetic poetry sets and all the different rooms, and he comes back with a bucket, and then they throw the bucket of words out onto the ground, and then you start to go into the clustering of these words. So like what percentage, what's the likeliness that this is going to be the word that fits in this blank? And so you've got these kind of set up into clusters, and the top P tells you, well, what's the top percentage of the clusters that you're going to choose that from? And so you go through, you look at it and go, oh, I'm going to put in perfect. So get it perfect the first time. That's what I'm going to choose for my word. And so now if you go through, and if you're a chatbot and now you change the temperature to 0, you can hardly put anything in there. Wordy goes out, looks through, comes back, and there's one word that it puts into the bucket. And it's get it right the first time. And the same thing with the top P. It's like, yeah, that's the only word that you can choose. And so the point here is that these models have these settings called temperature and top P and other things that control how creative it is and how random it is. And depending on where you set the temperature, you're going to get different results. If you're setting the temperature very low and the top P very low, it's going to be like Spock on steroids. You're not going to get very creative responses. And so when people talk about hallucination, it's a feature, not a bug. And so when people say, oh, it went out and used ChatGPT and it hallucinated, that's because ChatGPT is kind of set between 7 and 10 for the temperature, and the same thing for the top P. So it's going to be very creative in its responses. But you can create systems that are not as creative. The generalized bots are very creative, and the specialized bots, by the way, people complain about the generalized bots, like, oh, it wouldn't give me a good answer. That's like going out into a field, an Idaho field, picking up a raw potato, taking a bite out of it and going, yeah, that didn't taste very good. Of course it didn't. And so you create these specialized bots, and different companies have different names for their specialized bots. But when you get specialized bots, now you're talking the baked potato, got a little bit of something on it. Well, I went out and for you, I created a very nice, extra tasty baked potato, and I used this method of bot building. I gave it a persona, then I gave it general rules, and I gave it step-by-step instructions. And I created Atticus, a defense attorney that you could go out, you could talk with, and you say, okay, how would a defense attorney try to defend this? And then this bot can go out and kind of figure out, oh, well, here are some possible ways that a defense attorney would try to defend this particular case. And so I gave it all of these instructions, and I set it up so that it would be like this beautiful kind of baked potato. And I have a link here that you can go out and you can compare regular old Chat GPT to Atticus. And then it all fell apart yesterday because we had OpenAI come out with O1. And this is a completely new model that does advanced reasoning. It's like someone went out and grew a brand new sequoia tree in my backyard. And I just haven't had time to look at it all, to play with it all. But basically, what it does is it adds reasoning to this. And so when you hear people talk about, oh, we can't trust AI, we can't do this, it's moving so fast that very soon you are going to be able to trust it. It's going to be more reliable than human beings. We're already seeing that if we go down here and we look at this was what human beings were capable of when that guy wrote that thing out and got caught. All right, he was using AI that was not very smart. It's much smarter now. It's smarter than Einstein. And what happened yesterday was they came out with a new model that's way up here. It's so smart that these benchmarks that they've been using to determine, well, which bot's the best, it's tapped them out. They really don't know how smart it is because they don't have ways to measure how smart it is. So when it comes to talking about AI and what you can do with it, the landscape is changing very quickly. And so you have to be willing to kind of don't when you hear something that's like, oh, AI, you can't trust it. We'll think, well, when did that happen? Because this stuff changes every few months. And you want to be looking at what's coming up in the future and having an eye to that. And so that's the message that I really want to get across to you today.